Dear students, welcome to my physics channel in YouTube, Pinas Physics Gyan. In our second class of projectile motion, I will discuss about time of flight and range. In my first class of projectile motion, I discussed about the height in projectile motion, where I derived the expression for height. In the second class, let us go to the expression for time of flight. My dear students, as I had already explained in my first class, horizontal velocity in a projectile motion will remain constant, and the vertical velocity, which is under gravity, it continuously changes its speed. As it go up, its velocity decreases. As it moves from highest point to the ground, its vertical velocity keeps on increasing. Okay, my dear students. And another thing you must know, the horizontal distance traveled or horizontal motion of a projectile motion, the responsible factor is the horizontal velocity, and for vertical motion, the responsible factor is the vertical component of the velocity. My dear students, out of this horizontal motion and vertical motion, vertical component of velocity, vertical component of the velocity is directly coming under the gravity. It will be similar to the body thrown vertically upward. Okay, my dear students. Then how to find the expression for time of flight? What is the meaning of the time of flight? Meaning of the time of flight is that if a projectile moves from the initial position O, projectile moves from initial position O to the maximum height P and comes back to the ground C. So time of flight is time of ascent plus time of descent. Time of flight is time of ascent plus time of descent. Okay, my dear students, time of flight, capital T, is equal to time of ascent. Time of ascent. Time of ascent means time in going from point of position O to highest point P, plus time of descent, plus time of descent, plus time of descent. What is the meaning of time of descent? Projectile to move from highest point P to the ground, back to the ground. Okay, and in any gravity controlled motion, the time of ascent is equal to time of descent. You have already read in your school career, I mean in the class 9 and class 10, you have already read when a body is thrown vertically upward, time to reach the maximum height and time to come from maximum height to ground is same. In similarly, as the vertical motion is controlled by the vertical component of the velocity, which is coming under gravity, time of ascent is equal to time of descent. Therefore, we can write time of flight is equal to 2 into time of ascent. 2 into time of ascent. Then question comes, how to find expression for time of ascent. Time of ascent. My dear students, as vertical motion of a projectile motion is similar to the bodies thrown vertically upward, we can use the equation of kinematics in a vertically upward motion. What are the equation of kinematics? V is equal to U minus GT, H is equal to UT minus half GT square, V square is equal to U square minus 2GS. But we have to use that expression which contains time. The time in equation V is equal to U minus GT, there is a term T. In equation H is equal to UT minus half GT square, there is a term T. So out of these two equations, which equation will be easy to apply and to find the time of flight? That is the V is equal to U minus GT. So we will use equation of kinematics, V is equal to U minus GT. If we apply this vertically upward motion equation in projectile motion, which is the vertical component of the velocity, initial vertical component of the velocity is Uy, and at the highest point, vertical component of the velocity is 0. To find time of ascent, our initial position is O, final position is P. So here, If we apply the vertically upward motion equation in projectile motion, this will be Vy is equal to Uy minus Gt, because the vertical motion is controlled by the vertical component of the velocity. Okay. So to find time of ascent, the final position is P, where the vertical component is 0. Initial vertical component of the velocity is equal to U sin theta minus G into T. Therefore, G into T is equal to U sin theta. Then time of ascent is equal to U sin theta by G. This is the time of ascent. Now, what is the time of flight, my dear students? Time of flight will be 2 into time of ascent. 2 into time of ascent is U sin theta by G. Time of ascent is U sin theta by G. Therefore, the time of flight is equal to 2U sin theta by G. Again, I am telling you, my dear students, how I have arrived at this equation, how I have just used the equation of kinematics of a vertically upward motion, and this vertically upward motion is similar to the vertical motion in a projectile motion. Okay, my dear student, let us move to the range in projectile motion. My dear students, I had already explained in my first class of projectile motion, the horizontal component of velocity in a projectile motion is constant. It does not change. Okay, my dear students, what is range? Range in the horizontal distance traveled by the projectile. The horizontal distance traveled by the projectile is due to the horizontal component of the velocity. H, because this is constant, where the speed is constant, distance is equal to speed into time. Therefore, here range is the horizontal distance traveled. Range is the range R is the horizontal distance traveled by a body under projectile motion. Horizontal distance traveled. This is horizontal distance covered by a projectile motion. What is the horizontal distance? It is because of the horizontal velocity. Horizontal velocity is constant, so the velocity into time will give you the displacement, or speed into time will give you distance. Okay, my dear students, a speed is constant, the speed into time will give us horizontal distance, that is equal to range. So horizontal velocity or horizontal speed into time of flight, because the total time for which projectile motion is in the air is equal to time of flight. So therefore, we will multiply horizontal speed with time of flight. Time of flight. Okay, my dear student. Then what is our range? U cos theta. Time of flight, we have just derived the expression for time of flight. What is time of flight? In the previous page I had explained. You see, in the previous page I have told you what is the time of flight. Okay, my dear students. Now you multiply U with U, that is equal to U square, 2 sin theta into cos theta. I am bringing 2 sin theta into cos theta together by G. Okay, my dear students, then range is equal to U square, 2 sin theta into cos theta. You have already read in your trigonometry, 2 sin theta into cos theta is equal to sin 2 theta. So expression for range is U square sin 2 theta by G. U square sin 2 theta by G. So expression for range in a oblique projectile motion is equal to U square sin 2 theta by G. Now let us move to this particular diagram. You see, there are 3 persons or 3 boys are there. They have thrown stones. They have thrown stones with same speed U. With same speed U, making different angles with horizontal. One person has thrown with angle of projection alpha, other person has thrown with angle of position beta, and third person has thrown with angle of projection gamma. But for all the students or all the persons, the speed of projection U is constant. Our expression for range, as we had just explained, I had just explained U square sin 2 theta by G. U square sin 2 theta by G. As U is same for 3 persons, acceleration due to gravity on the ground is constant. Therefore, as U is same and G is constant, range will be directly proportional to sin 2 theta. When the range will be maximum? Range will be maximum when sin 2 theta is maximum. So range will be maximum. Range will be maximum when range will be maximum when sine 2 theta is maximum. When sine 2 theta is maximum. You have already read in your school career the maximum value of sine theta is equal to 1 and sine theta is equal to 1 at an angle of 90 degree. Therefore, 2 theta is equal to 90 degree, then theta becomes 45 degree. It means if the speed of projection is same, at what angle of projection range will be maximum? When the angle of projection is 45 degree, range will be maximum. Then what is the value of the maximum range? What is the value of the maximum range? R max. What I had made? Sine 2 theta equal to 1. Sine 2 theta is equal to 1. U square into 1 by G. That is equal to U square by G. Or you can say R is equal to U square sine 2 theta by G. Sine 2 into theta, what we have found? Just 45 degree by G. It means again U square into sine 90 by G means U square by G. So range maximum is equal to U square by G. It means you see here which person is thrown with angle of projection 45 degree? The person which is thrown, which is given in the white color. So here angle beta is equal to 45 degree. The person who is thrown with angular position 45 degree, its range will be maximum, as I have shown in the diagram. Okay, my dear students, then range maximum is equal to U square by G. Another thing, we'll find a relationship. Just you see, my dear students, just you see what we'll do here. When the range is maximum, you see, when range is maximum, when angle of projection is 45 degree. Here range is maximum, and maximum range, we have just found the value of maximum range, which is equal to U square by G, and this is the height. Now we have to find relationship between height and maximum range when range is maximum. Or what I mean to say, what is the relationship between height and range when range is maximum? Range is maximum when angle of projection is 45 degree, which I had already explained. What will be the height when range is maximum? What is the formula for height? U square sine square theta by 2g, which I had explained in my first class of projectile motion. Please go through my video. U square sine square theta by 2g. So here angle of projection is 45 degree because range is maximum by 2g. Sine 45 degree is equal to 1 by root 2. This is 1 by root 2 square divided by 2g. This will become U square by 4g. It means when the range is maximum or angle of projection is 45 degree, the height becomes U square by 4g. U square by 4g. Here height becomes U square by 4g. Let us find relationship between height and maximum range. You see what we have found? H is equal to U square by 4g. What I'll do here? 1 by 4 into U square by g. What is U square by g? U square by g is range maximum. Range maximum. Therefore, R maximum is equal to 4 times height. 4 times height. What we have learned here, my dear students? When the range is maximum or when the angle of projection is 45 degree, this range maximum is equal to 4 times the maximum height. This is what? This is the relationship between height and range when range is maximum. Okay, my dear students, I believe the expression for time of flight and range, which I had just explained, you would have understood it thoroughly. In my next class, I will discuss about the equation of projectile motion, and there I will tell why path of the projectile motion is parabola. Till then, goodbye.